Negative, right? It's negative to shake with your left hand. So use your left hand for negative charges, right? It's a subtle thing, but it's real easy to overlook or forget, so that's why I point that out. So the magnetic force will actually be upward. So it's going to have a positive y value, and the deflection is going to be in the positive y direction.
That's at first, like.
So it's going to actually go like this.
Explain the rule. So
Finger in the direction of the field.
Yeah.
Or I'm sorry, in the direction of the motion.
Mm-hmm.
Fingers in the direction of the field. Now, if it were a positive charge, like a positive current, the force would be downward. But because it's an electron, it's upward. Or if you use your left hand, like that. Direction, field, force.
Yeah.
So negative charge. Yeah, that makes sense.
Just flip it around. I would just think about it, do the cross product first, and then multiply the charge from the metal side. Right.
So
Because you have negative.
the magnetic force, and you could have just as easily did the cross product, right? So you should do that, right? We got negative V and we've got V cross B. V is whatever its velocity is in the I direction. B. Now normally, let's see, we've got an X, we've got an X, we've got a Y. Typically the Z direction is in the board, right? Yeah. The Z direction is normally in the board. So even though I've got it pointed outward, it's usually actually better to think of the X direction this way, the Y direction that way, and the Z upward. But based on the way I did it, Z is probably best into the board. Doesn't matter, again, you can pick it out by directions, but the reason I point that out is that B should have a value of negative 3.0 Tesla in the K direction.
Oh, so we did it the X, Y
Yeah,
that way.
yeah. Just the way I did it, I
Yeah,
shouldn't have done it that way.
Yeah, you said it was coming out.
Yeah, it's coming out, so it'd be the negative K direction. If K
Oh,
is in.
if you said K is in, then you said positive Z.
Messing with me.
Okay, so
That generally
I agree. So what does that do with all of this then? It's going to be in the Y direction because we have a K-I-V-V relationship. So it's going to either be in the positive or the negative J direction. Just because the plane of the force will be perpendicular to the plane of V and V.
Yeah.
So however you look at it, it's going to end up
now
being.
that it'd be going down, right?
So you've got a positive here, a negative there, a negative there, and then the only question is the cross product going to put us in the positive or
Cross
negative?
product, that's it.
Does it?
All right.
Well, make sure I've got the Z direction in the right place. So,
I cross K is negative J.
Yeah.
I cross K is negative, okay?
Yeah.
Negative, negative, positive, negative. So
It'd be going
X,
in the negative
Y,
direction.
Negative.
Z.
So it would be-
I pull it over this way, and then pull it over this way, Z's in the other direction. You see? Can't trust me at all.
Positive's coming up.
Z is coming out.
Mm-hmm.
That was my problem. So I lied to you.
All right.
You gotta just twist it, right? Like a jacks. Jacks, you should kind of twist it.
So now we have P being positive again?
Yeah, so it's a positive,
It's positive.
because I lied to you. This is a positive. I figured it out by minus signs anyway, eventually. Right? So you end up getting a minus E, whatever V is, B, and then it's in the minus J direction. So the minuses cancel out, whatever that is. What is V? I don't even know what V is. I
Is
just,
that 4.2 times 10 to the 6th?
That's what I've got, yeah.
I concur.
Million meters per second.
Not that fast.
okay, so it's times 10 to the 6th. What was that first number again?
4.2.
Okay, so you end up getting 12 times 10 to the 6th times 1.6 times 10 to the negative, whatever.
I get about 2.02 times 10 to the negative 12.
Nope.
And what is the unit on this thing?
Well, let's just put it
Yes, it's
together.
just
So it'd be what? 2.02 times 10 to the negative 12.
Correct.
And the unit should be Tesla meters per coulomb, or coulombs per second. Now a Tesla should be a Newton per coulomb meter. It should be a Newton second per coulomb meter.
Second.
So if we plug those in there, the seconds come out, meters come out, and you're left with
Newtons.
Newton.
Oh, it is Newtons.
It better be Newton.
Of
If it's not, we got other trouble.
You got the new shoe, bro.
So the magnitude is 2 piconewtons, but the direction, at least initially, would be positive y direction. And then, so where does it exit the field?
We gotta solve for R and then double it, and it'll be 2R above where it is.
Yeah. So if it enters the field here, it's gonna do this. And if this is a radius of R, it's gonna travel 2R to get out. Make a half circle. Now, there's a lot of different ways to calculate this. The easiest way is just to say mv squared over r is equal to fb.
Of course.
So r should go as mv squared over fb, which should go as 2 times the kinetic energy over FB. And you already calculated the kinetic energy. Or, if you will, it's 2 times Q delta V when it was in the electric field, if you didn't calculate that piece, divided by FB. So if you double this, double all of this stuff,
7.9 times 10 to the negative 6 meters.
so
Oh yeah, we're gonna double it again, so it'd be
we have 4 times 1.6 times 10 to the negative 19th coulombs. And we had, wasn't it like 50 volts? 1,000 times 0.05. So 1, 2, 1, 2. So it's, yeah, it's 50 volts. Not a lot of field. And then we divide this by 2 times 10 to the negative 12 newtons. And by the way, a volt is a Newton meter per coulomb. So the coulombs go away, the newtons go away, and lo and behold, we have units of meters. So, good thing to double check. Ian's not here to check those units for us. But we can do it anyway, in spite of that.
1.6 times 10 to the negative fifth meters.
So, did you say 1.6
Yeah,
times 10 to the negative 12?
no, fifth.
Or negative fifth meter?
For, R?
For
Or for
2R.
2R?
Oh, for 2R. Why would it be 2R? Because that's the new sheet.
So, let's make this an engineering question. Take our break. Two parts to this. We'll do the first one before the one. Okay, so here's my question. What voltage would you need to accelerate this charge through? Oh, here's extension number 1. What delta V will result in n squared? Okay, so we want this charge now to exit five centimeters above the entry point. Okay, in other words, think about this being where the electron travels through, but the distance that we're concerned with, and we might basically put a detector here. If I put a detector over here, at a distance of, so there's entrance, here's your magnetic field, and over here is a detector. And the distance above is 5 centimeters. So what type of a delta V do you need to get this electron to come out there? Delta V over here, and we've got the charge right there. This radius is R. Something like that. And the B field is over here. Just a rearrangement step. But
Anybody get a number for part 4 yet?
oh, I forgot.
We got a really short period of time. 5.95 times 10 to the negative 12 seconds.
It's going to be pretty darn fast, right?
Right.
Regardless, because it's going a million meters per second, and it's only traveling a distance of
Pi r.
pi r over 2, yeah.
Yeah, it should be just pi r. If 2 pi r is the full circumference.
Oh, 2 pi, I'm sorry, pi r, yes. Okay, do you convert omega into seconds?
What?
2 pi times the frequency is omega. So to get the time, that's 1 over the frequency. So it's going to be 2 pi over omega. Something like that.
I just get pi r over v.
That works too.
Which is pi omega.
What did we say omega was? Well, first of all, the frequency is
So it's 1 over
Is-
omega.
omega over 2 pi. So the time for 1 period should be 1/2
Mm-hmm.
1 over the frequency.
Mm-hmm.
So 2 pi over omega. And think of pi in radian units, omega in radians per second units, and you'll get units of seconds. Now to get omega, this one, but I've already forgotten what it was. So to get omega, it had something to do with Q, B, over M. First time we have to actually calculate M. Do those units look right, or there's something? So that's a Tesla. This should have units of inverse seconds, right?
Okay, so the delta V,
Well, you're doing 1 over omega still, so it will be.
Meters cancel out, kilograms cancel out. Yeah, no, it works out.
It'll flip up.
Double check in my units.
4.9.
So I got 1.4 times 10 around 37.
Is that 3.000 Tesla or 3,000?
That 3,000 Tesla?
Oh, 3 Tesla. Like I said, it's 3 Tesla.
Like you said.
I was confusing with my magnetic or my electric field.
Very accurate.
Sorry, I'm sorry. I'm all over the place. I have no idea. So it's what, 4.8 divided by 9? It's about 0.5 times 10 to the 7? Or no, not 7, excuse me. 12. Negative 12? Or 12, positive. Positive 12.
And that 1.270 is what?
Something like that. Just, is that about right?
Oh.
5, yeah.
Yeah, I didn't do
That's
that.
exactly right.
Okay, so you do it a different way, that's okay too. I'm just, this is just happened to be the way that I
If it's gonna exit.
Think.
set it up. So the exit time would be pi over 5.3 times 10 to the 11 seconds. And this is going to give us 10 to the negative 11th, and then it's going to make it negative 12. And it's 3 divided by 5, so
It's 5.95.
But you have the same answer.
Just be safe on zero.
yeah, I'm just using that relationship that we calculated for the frequency. Okay, just, yeah, it's just. I'm not even hungover, that's the weirdest part. I just didn't get my coffee, I guess I had my second cup today. I don't know, I can't explain it. All I can do is apologize because I can't. I just woke up so relaxed today with this 3-day weekend. I'm not even here yet. I know it is unacceptable, it's absolutely unacceptable. It's one of those days I can sit at my desk and just calculate without having to actually talk. Yeah, you always have those days. Okay, so short. Now we'll come back to the question at hand. So we've got this electron in this electric field, or this voltage, if you will. So take your break now, we'll come back and we'll get to this. Same problem, it's just what voltage do we need to get this thing?